Hi, this is Mr. Weisenfeld. I just want to go over a walkthrough of the standard PS1, Newton's first law. We'll talk about the objective for the standard and then what you need to show proficiency at level 1, level 2, level 3, and level 4 in that standard. So let's get started. Newton's first law, you need to apply Newton's first law to explain how balanced and unbalanced forces affect the motion of objects, and then utilize technical design process basically to illustrate Newton's first law. So Newton's first law, simply put, in the absence of an unbalanced force, so unless there's an unbalanced force, an object will either stay at rest if it's at rest, or if it's moving, will move at a constant velocity in a straight line. Okay? Put a force on something, that all changes. Something at rest will start moving, something that's in a straight line will start moving in a different line. That's a consequence of this law, but first law stated simply is an unbalanced force, straight line, or at rest. You need to have those three ingredients: unbalanced force, at rest, staying at rest, or in motion, staying in motion at a constant velocity. So what you need for level 1 in this standard, you can state it just like I did. State Newton's first law, three ingredients: unbalanced force, at rest, or motion, straight line. Then you need to define inertia. Inertia, like Galileo's principle of inertia, inertia is the tendency of an object, if it's at rest, to stay at rest, or if it's in motion, to move in a straight line. It's also like mass, okay? So inertia, define velocity. Velocity is speed, change in distance over change in time. An unbalanced force is what's left over, like a tug of war. If somebody's tugging and they're tugging harder, there's more force this way. That's the unbalanced force. It's what's left over after you subtract out all the other forces. It's like the net force. It's like the resultant force. All those words we use for unbalanced force. Acceleration. Acceleration is a change in velocity per change in time. So it is something is either speeding up, getting faster, or slowing down, getting slower. Boundary forces. Friction. Friction acts opposite to motion, tends to slow you down. Frame of reference, like how you look at motion, depends on how you're going to measure it, or how you look will affect how you measure it. So if I'm in a car versus outside the car, I see things differently. And then motion overall. So you need to define those. You need to state the first law. That's all for 1.0 level proficiency in this standard. Level 2, free body diagrams. What's a free body diagram? It's like a cartoon or a simplification of a system. You draw a box, you draw some arrows against it, coming from it. That's a free body diagram. It's a simplification. And then identify how friction affects Newton's first law. So friction tends to slow you down. Friction tends to take energy out of a system. Okay, that's all for level 2. Level 3, you will pass this standard if you can do the following. Explain and demonstrate the effect of mass on Newton's first law. Mass, like inertia. The more massive an object is, the more force you need to get it to accelerate. The less mass for a same force, the more acceleration you get. And then different forces, how do they affect motion? Balance versus unbalanced. If forces are balanced, tug of war, nobody's moving, things stay at rest. Or constant velocity, pushing the same, velocity doesn't change. No force, no net force, no acceleration. No net force means balanced forces. Unbalanced forces mean acceleration in the direction of the unbalanced force. Then, level 4. Can you make predictions based on stuff you've seen with Newton's first law for your own system in your own way? That's what we're doing for above 3.0 level proficiency on the standard. Once again, this has been an evaluation of the learning progression. Sorry, this has been a summary of the learning progressions and the objective for Newton's first law, PS1.